look at our world, a familiar globe of blue and white, and we assume it was always so. We see a planet of stable, life-giving air, an atmosphere breathable and balanced, a given fact of our existence. We believe this world was shaped by inanimate forces, volcanoes, tectonic plates, the slow, grinding march of geology. But this is an illusion. The greatest forces that shaped our planet were not rock and fire. They were life. 3.5 billion years ago, the Earth was an alien world. Imagine a sky not of blue, but of a murky, reddish-orange, choked with methane and carbon dioxide. Imagine an ocean, not of blue, but of a pale, acidic olive green. This was a world without oxygen. It was a planet of potent poisons, a chemical broth simmering under a younger, weaker sun. And in this toxic soup, life had begun. But it was not life as we know it. It was a shadow biosphere of single-celled organisms, anaerobes, life that lived in darkness, that fed on the sulfur belching from volcanic vents, that thrived on the very gases we would find lethal. They were the undisputed rulers of a silent planet. And then, something happened. A revolution. In the shallow, sunlit waters, one of these simple microbes developed a new trick, a piece of molecular machinery, perhaps borrowed, perhaps invented, that would tear the world apart and rebuild it. This tiny organism, a form of bacteria we now call Cyanobacteria, was unremarkable, a microscopic speck in a vast, hostile ocean. Seen by any observer, it would be dismissed as nothing, a footnote in the story of a sterile planet. But this was a profound misjudgment. This bacterium had learned to do something that its anaerobic cousins could not. It had learned to eat the sun. Through a new process we call photosynthesis, it harnessed the energy of sunlight, combined it with carbon dioxide and water, and created sugar for itself. It was a metabolic miracle, an engine of infinite energy. This tiny engineer had tapped the greatest power source in the solar system. It began to thrive, to multiply, to spread, a living green-blue film creeping across the surface of the primordial sea. But, and this is the pivot upon which our entire world turns, this miraculous new process had a waste product, a byproduct, a gas so volatile, so corrosive, so dangerously reactive, that it was a lethal poison to nearly every other living thing on the planet. This microbe, this Cryptobacterium, had invented a toxin that would rewrite the very chemistry of the Earth. It began to release oxygen. The great engine of photosynthesis had been ignited, trillions upon trillions of microscopic cells, all breathing in sunlight and breathing out this new toxic gas. But the oxygen did not at first touch the sky. It remained trapped in the ocean, and here it met its first reactant, iron. The primordial oceans were saturated with dissolved iron, giving them their pale green tint. The new oxygen immediately latched onto this iron, binding with it. The result was rust. For hundreds of millions of years, the planet began to rust, a slow, relentless precipitation of iron oxide raining down from the sunlit waters to the dark seabed. This was not a small event. This was an act of planetary-scale engineering. As the cyanobacteria flourished, the oceans of the world, one by one, turned from green to a deep blood red, choked with oxidized iron. This event, known today as the Great Oxidation Event, is not a theory. It is a scar written into the crust of the Earth. Today, we mine this legacy, the vast banded iron formations across the globe, the source of our steel, our cities, our civilization. They are the fossilized remains of this first great act of biological engineering. They are the graveyards of a world transformed by a microbe's breath. As paleogeologist Dr. Aris Thorne might observe, we are not just looking at biology, we are looking at the single largest, most profound chemical event in Earth's history. These microbes were terraforming the planet, one molecule at a time, with no foresight, no intention. They were simply living. This process of planetary rusting continued for an almost unimaginable span of time, perhaps 500 million years, 1,000 million years. The cyanobacteria kept pumping out the poison, and the ocean faithfully absorbed it, burying it on the seafloor. But no system can absorb such a change forever. Eventually, the sink was full. The dissolved iron in the oceans was gone, spent, locked away in stone. The oxygen, still being produced relentlessly, had nowhere else to go. And so, it began to leak. Molecule by molecule, it escaped the surface of the water and entered the atmosphere for the first time. This was the true beginning of the catastrophe. For the dominant life on Earth, the anaerobic empires that had ruled for 1 billion years, this was the apocalypse. Oxygen is a biological fire. It tears apart organic molecules. It destroys the delicate machinery of cells that are not equipped to handle it. To these original inhabitants, this new gas was a suffocating, corrosive plague. A slow-motion mass extinction event began, the greatest the world has ever known. Entire ecosystems of anaerobic life were wiped out. The rulers of the planet were driven into the dark, airless corners that remained, the deep mud, the hydrothermal vents, the places the oxygen could not reach. Their world was stolen from them by an upstart engineer, and its toxic waste, the cascade, was now in full motion. As the oxygen flooded the atmosphere, it encountered another gas, methane. Methane was the blanket that had kept the young Earth warm, but oxygen reacts violently with methane, destroying it, turning it into carbon dioxide and water. The planet's thermostat broke. As the methane haze was stripped from the sky, the Earth rapidly cooled. The sun was still weaker than it is today, and without its greenhouse blanket, the planet was plunged into the most profound ice age in its history, Snowball Earth, a world entombed in ice, perhaps from pole to pole, for 300 million years. The very engineer that invented this new world had in the process frozen it solid. We stand now, 2.4 billion years in the past. The world is unrecognizable. The Great Oxidation Event has fundamentally altered the planet. The rusted oceans are clearing. The methane sky is gone, replaced by a new, thin, pale blue. The planet is a sphere of ice. It seems perhaps that the experiment of life has failed, that the engineer's work has resulted in total destruction. But this is the profound irony of ecology. What appears to be an end is almost always a beginning. Beneath the ice, in the sunlit cracks and the warmer equatorial waters, the cyanobacteria endured. And more importantly, life adapted. In the crucible of this new, high-poison environment, a new form of life was evolving, a new kind of cell. This cell did not just survive oxygen, it learned to use it. It developed a new metabolic engine, one we call aerobic respiration. It domesticated the poison. It took the most dangerous, reactive chemical in the environment and turned it into the most potent fuel biological systems had ever known. This single evolutionary leap was the second great act of this story. The anaerobic life that fed on chemicals was inefficient. The photosynthetic life that fed on the sun was revolutionary. But this new aerobic life was a superpower. Breathing oxygen allowed for an energy budget tens of times greater than anything that had come before. This high-octane fuel was the gateway to complexity. When the ice finally retreated, it was this new kind of life that inherited the Earth. The poison had become the prerequisite. Without oxygen, life would have remained simple. There would be no cells large enough to see, no cooperation, no multicellular organisms, no plants, no fish, no forests, no dinosaurs, no primates staring at a computer screen. The entire story of complex life, of movement, of thought, of consciousness, is built upon the toxic waste of a microbe that lived 3 billion years ago. The irony is staggering. The single greatest act of pollution in planetary history was the very act that made our lives possible. The Cyanobacterium did not just destroy the old world, it created the fertile ground for the new. It was the necessary executioner and the unintentional architect. What if this revolution had never happened? What if Castor never built its dam, Atta never farmed its fungus, or Cyanobacteria never polluted the sky? We would be living on a different planet. Earth would still be a shadow biosphere, a quiet, murky world ruled by simple anaerobes, trapped forever in its microbial infancy. A world of slime, no birdsong, no whalefall, no human cities. We do not just live on Earth. We live in a world constructed piece by piece by the engineers that came before us from a single cell, a new way to process sunlight, a chain reaction that unfolded over 1 billion years, an ocean of rust, an atmosphere of poison, a planet frozen and reborn, an evolutionary arms race that turned a lethal toxin into the fuel for all complex life. This is the legacy of the Cryptobacterium. It forces us to ask a fundamental question. What is life? Is it merely a passenger, adapting to the geological whims of its planet? Or is life itself the most powerful geological force of all? This single microbe did not just adapt to its environment. It built its environment. It engineered the air. It redesigned the oceans. It set the stage for every single living thing that followed. Every breath we take, that deep, satisfying pull of air, is a ghost. It is a testament to that first great revolution. The atmosphere is not a static, chemical given. It is a biological construct, a living quilt, woven, maintained and balanced by microbes, by plankton, by forests over eons. The history of Earth is not simply geology, it is biology. And we are just the most recent engineers, wielding a power we barely understand on a world built by those who came before.